So first thing is we will have both assignment 1 and assignment 2 set up on OJ. Definitely assignment 1 will be set up on OJ by tomorrow. So that during tomorrow's lab session, you should resubmit your assignment 1. You should submit your assignment 1 rather on OJ. So in order to do that, you may have to slightly modify your program input and output format so that it matches what OJ expects, because it's an automated evaluation system. The input and output should be in a specific format, and that specific format will be given as a part of problem description itself. So for assignment 2 also, I will ask the TAs to get it ready by tomorrow. And so that is the plan for that's the plan for tomorrow's lab session. There will not be quiz because I would like all of you to get good practice on the OJ. Quiz we will have it sometime next week. Okay, I will let you know in advance. So now assignment 3 will be released today, and it will be very interesting assignment. Let me share what that assignment will be. So I will post it, and also I will do one more thing. By this weekend, I will have the e-learn set up so that it will be easy for you to follow the video lectures. So that is that we will do. And so far in the first assignment, you have seen you solve the problem of finding dot product between two vectors. Dot product of two vectors. This problem you have solved in the first assignment. And now in the third assignment, we will continue this thread. So, you know, dot product of, you will do one problem you will be solving is you will solve a bunch of problems related to matrices. So one problem that you will be solving is you take a matrix and multiply it with a column vector. Okay, so this is like this. So when you multiply an m by n matrix with an n by 1 matrix, what is the dimensions of the resultant? Matrix, what is the dimensions of the resultant matrix? M by 1. You all studied this, right? I hope you all studied this one. So here, if you see, this is row 1, right? So this is row 1, this is row 2, so on and so forth. This is row M. And let's call this as, this column C. This is a C. Then the first element of the resultant column vector, which is m by 1, what is the first element of the dot product of R1 and C? Okay, so R1 dot C, and our second element is R2 dot C, the dot product, so on and so forth. This is how you compute a matrix vector product. So you will solve this problem in your assignment 3. How do you multiply a matrix with a vector? Third problem is how do you multiply two matrices? Okay, so matrix A times B. So if you think about it, if you are multiplying a matrix A, let's say the dimensions of this matrix are, let's say what, Mn. Yeah, so it has, you can think of the first matrix as a collection of rows. Okay. And the second matrix, let's say there are O columns, MNO. Okay. Yeah. So now, is it possible for us to think of the second matrix as a collection of columns? Do we lose any generality or do we lose out anything if we think of the second matrix as a collection of columns? There are O columns. It would be the same, right? It's just a different perspective. Yeah. So now the interesting thing is, how do we, what is the first row of the product matrix? Or what will be the first column of the product matrix? Let's say, what will be the first column of the product matrix? The first column of the product matrix is, it's just like R1C, R2C, so on and so forth, right? Is it safe to say that we can just, the first column of the product matrix is A times C1. Excellent. Sri Teja put it nicely. Okay. And the second column is matrix A times C2. Yes or no? The second column is A times C2. Matrix A times the second column. So on and so forth. So this particular view of matrix multiplication will help you write your program to compute product of two matrices. Are you all with me here? Okay, good. And then you will solve one more problem, one simple problem. Matrix transpose operation, right? You just, yeah, great. So like that, few simple problems, these are all kind of, warm-up problems for assignment 3. And the actual set of problems, or I will share them. They come from the space of numerical methods. Let's see. Are you able to see the screen? Today I am logging in from home. So from home, I'm not actually quite used to taking classes, but today I'm trying it out. So this link I will provide you. So what we will do is we will start with a very, here in this space, this problem, given a quadratic equation such as 2x square plus 3x plus 2, what are the roots of the quadratic equation? This is easy, right? There's a formula for it. There's a closed form formula for this. So it's not really a big deal. So this is very simple. So we start with this problem, but then after that, so there are a bunch of, so for generic, if we are working with a general polynomial or an arbitrary function, then there are methods for computing the root of a function, like bisection method, Newton-Raphson method, secant method. I know about these three methods. False position method, I don't know. I have to check that. So these you will write programs for these algorithms. Okay, like how do you finding the root of the equation? You will learn quite a bit during this process. And then you will learn about all these, you'll write programs for them, and then coming to, so this is the first, what you have seen earlier, there is the first set of problems. The second set of problems will be related to this. How do you find the roots of functions? Okay, roots of equations. And then we move on to the third set of problems where we try to solve simultaneously linear equation. You all know Gaussian elimination method. You convert it into a lower triangular. You may not have heard it that way, but what do you do when you're trying to solve? You convert it into a lower upper triangular matrix or lower triangular matrix. Did you learn it in your +2? Gaussian elimination method? Okay, we will learn. It's not a big deal. We will learn. Okay. Yeah, so anyway, so you will learn Gaussian elimination method, and then LU decomposition, and then Gauss-Seidel or Gauss-Jordan method, and finally, how do you find the eigenvalue using what is called as a power method? So there is a third set of problems. Okay, so all these things put together, you will have approximately, at least a dozen problems. For all these problems, you need to understand the algorithm. There's good, nice math behind it. And how do you take it and then actually implement it, make a write an algorithm and test it. It is going to be interesting. You will learn a lot and in this process. Are you doing linear algebra course this semester? No, right? Okay, you don't need to know full linear algebra. Some basic linear algebra, I'll post some videos. You should be able to watch them and get it. Okay, are you all excited? I will give you 2 weeks to solve this problem because you need to understand this, and I will post the questions in this class, and by today, tomorrow I will post. And all these things, very, very nice problems. You will see many interesting ideas along the way when you solve them. Okay, so that is about yeah. So that's about the assignment 3. Yeah, all going forward, everything will be on OJ because it's easy to evaluate on OJ. Okay, but we will not give the initial OJ format. We would initially like you to solve the problems with an appropriate input and output, and after that, what do you mean by you will solve the problems only in the course? No. There is more stuff to learn. We will switch back. We'll solve. We'll spend on algorithms, and then again we'll switch to some C language features, which are important. Okay, but the most important C language features you already know. Okay, so because it's not at over. How do you read things from files? You know, how do you use macro processor in a flower fashion? Do we learn other languages? You should be able to learn. That's what, you know. So when Professor PJN says in the first, in your orientation course, what did Professor PJN told? Our director, you will be prepared for your last job. How do you prepare for last job? We cannot teach you what you will be doing in the last job, but how do we go about learning something new? Okay, so yeah, so you will learn C++. I think there is no course which teaches you C++, but during your summer break, or you know, after this course is over, you should learn C++ on your own. Okay. All right, now, so let's, so now I want you to, some of you might be a bit unhappy about, let's see, let's go back and I will, about the problem that we solved. What is this? Enumerating yeah, the Pythagorean triplets. Yes. So in the Pythagorean triplets problem, what did we do? So we started with the hypotenuse value is equal to h is equal to 1. We checked if 1 is a possible hypotenuse, and we went for h is equal to 2, so on and so forth. This is what we did. And for a given value of h, let's say for h is equal to I, what did we do? Initially, what we tried is, we tried out S1. So strategy 1, checking hypotenuse, whether a given h, the algorithm for, so check hypotenuse. So algorithm 1, algorithm 1 is a very dumb algorithm, right? So we try out all possible values. We try out all possible values, and so what is the time taken here? It is h square, right? H, we try out all possibilities. So if you see, this is S1, this is S2, and then we try for 1 to H. For the sake of simplicity, let's say we are just trying from 1 to H minus 1, 1 to H minus 1. And how many entries are there? Approximately there are H square entries, right? Yes or no? Approximately there we are trying out H square entries. Are you all with me here? And how did we we said, it doesn't make sense to try out everything, because if you see, this is ith row, this is jth column. So if you see ij, no, you are trying ij and ji 2 times, so it doesn't make sense. So you either try ij or ji, only one of the two. So what we did is we, in algorithm A2, so what we did is S2 starts from S1 to H. So we traversed only the upper triangular matrix. So we went here, so on and so forth. And because of that, our running time, the number of times we iterated, the number of checks that we made is H square by 2, approximately. Now the question is, are you also fine with A2, that H square by 2 makes sense? Okay, that is approximate. When we are trying to find, we want to, how our algorithm is performing, we try to get some estimate of it. We don't need exactly what is happening. Okay, approximately what is happening, we need to get a sense of it. And now we want to see if you can, but many of you, as I was writing the code, you are mentioning, so why the approach that you are, we can do better than this. So what is the better approach? The better approach is, so let's say, so given H, okay, what do? We try different values of S1 to H, but then we compute K is equal to H square minus S1 square and check if K is a perfect square. Does this make sense? If K is a perfect square? So how do we check K is a perfect square? So we try to compute square root of K, okay, and yeah, so, and then you, in C language parlance, yeah, depending upon the approach that we use for computing square root of K, even though K is a perfect square, we may not, like for example, when we try to compute square root of 4, in the best case, you may get something like 2.00001, something like that, or 1.99999, because the way things happen in the what do I say, in a computer, the way arithmetic happens, it will have an impact on how we get square root of 4, whether it is what kind of approximation we get. But with high probability, if we round square root of K to an integer and then check it, but then even if you round, so checking whether it is an integer or not, it's not an easy, it's not easy. Okay, so there are issues around this approach, checking whether using the square root function and checking, there are problems in this approach. An alternate way of doing it is, how many of you tried this approach? Did anyone try to use square root function and do something? Did it work? It works until it don't work. Okay. There will be, so that's where you have to be careful. It will work sometimes, there will be some boundary cases, and and then no, those boundary cases it may not work, and the case that which didn't work, no, it may lead to some missile crashing or a rocket crashing into ocean or something like that. So yeah, so we should not rely on these tricky approaches. We need to have a clean approach to solve this problem. Yeah, so are you with me? Because of the representation issues, there are approximations coming in. The approximations are, there is the representation of 2.0 itself is an approximation. 2.0 may not be exactly represented in the computer, so it will be an approximation, and when you compute square root, again an approximation will come in. How do these combination of approximations work for different kinds of numbers? We have to kind of be very clear about it, theoretically argue about it. So when you write the programs, you should be careful about taking this doing this kind of things. So checking square, what do I say? Yeah, so one way of doing it is we try, whether 1 star 1 is less than or equal to, we check if 1 star 1 is equal to k, 2 star 2 equal to k. We keep running a loop. At some point, there are two possibilities. At some point, you get I star I equal to k. This is, so if this is the case, we stop. Or the other case is I star I is greater than k, at which case you will come out of the loop. Are you with me in these two cases? That we keep going, and then this is case 1. This is the way to terminate the loop, and this is case 2. And what is the bound on I at which, upper bound on I at which you will sure come out of this? So is you will can we safely say if I is greater than or equal to h, then the loop terminates? Is it okay to say that? Loop terminates if I is greater than or equal to h. Because if I is equal to h, then we have h into h is h square, and k is equal to h square minus s1 square. Okay. So how many times we iterate? This whole iteration count, worst case, iteration count is approximately h. Do you see the analysis of this problem? So how we moved from h square to h square by 2 to h? Then we may get 3, 4, 5 and 4, 3, 5 repeated. The last algorithm is also h square by 2. How is it? Oh, okay. We try for different values of S1. I see. Okay. Good. So, yeah. So we are trying for different values of S1. And for every S1, no, the count, we are still trying out H times. So it is still, yeah. I thought we improved it, but it's not the case. Good, good. Gnan Prakash has an approach, but the approach that I have suggested seems to be not working so great, because still we have to go till H. Okay, because for every value of S1, yeah, so we still spend time. Yes. All right. Okay, so short down. So but is there any advantage in this approach versus just trying out everything? But this seems to be we are doing clever, no? Is there any advantage in this approach? We can decrease the number of values of S1. The last loop can be till square root of H. How is it? Okay. H, it can be till square root of H. I don't need to go till. No, not really, right? Okay, think about it, how to improve this. We can go till H by 2, and there are few tricks that we can do. Okay. So Divij, when we put that also, no, we go till all the way till H, right? Yeah, as S1 increases. Okay, Sri Teja, Mayank send a video. So Mayank, you want to explain what is the algorithm? You sent it in the class, in the group. I didn't go through it. I will check. I thought let's give it a thought before we check another video. And then there are Sri Teja, there are some of you who have who understood the structure of the problem for structure of the triplets, and they have an approach for it. Okay, great. So good discussion. But in any case, will you be able to write code for this given this discussion? Like for example, checking the perfect square and all these things, the last approach, based on the discussion that we have, will you be able to write code? So this is how do we think algorithmically? And once we have an algorithm, how we can take that algorithm and go and write a C program. It's so that is what is important. Thinking independent of the language, the algorithmic idea, initially when we start thinking in terms of scanf, printf, and C language constructs. But as we keep moving, we should be able to do things without independent of the language. And once the algorithm becomes clear, then we go back and try to write it, express that algorithmic logic using the programming language that is there. It can be C, it can be C++. Yeah, submit challenge problem 1 also in assignment 1. What's the big deal? We already solved it, right? It's no longer a challenge problem. It's a challenge. A challenge problem in week 1 is not a challenge problem in week 3 of the course. Yes or no? Yeah, so it's no longer a challenge problem. Yeah. So assignment 1 will be released. So now I want to discuss a bit about the challenge problem from assignment 2. So what is the challenge problem in assignment 2? Let me open the problem and I will yes, assignment 2. I'm opening it up. Okay. Okay, you are able to see the screen, the problem. So here you're able to see the assignment 2, right? Okay. Now here I want you to, there's a very interesting thing that is happening here. How do you represent 100 floors, 32 rooms, 100 floors, 32 rooms? See, there is this question, what kind of input to take? No, you take some input later when the OJ comes, to modify it so that it matches the required input. Okay, so 100 floors, 32 rooms, one way of, so there's a hotel with 100 floors, 32 rooms. All the rooms are occupied by single male or female. Read this occupancy information. So one way of, so you said, first question I want you to think is, you said this is hotel 132. What is the data type of this? It can be anything. So like it can be int, okay, and we can make the element equal to 0. Don't use float, it's pretty bad, it looks bad. Floating point males and floating point females, okay. int yeah, int, or you can use int or short int. And what is the thing that you use? You can make it equal to 1 or 0 for female and male. Does this make sense? Okay, this is one way of doing it. Very simple way, use int, short int. This is one way of doing it. And of course, you can use, when you use int, perhaps no, the amount of memory required is 100 into 32 into 4 bytes. Okay, we are assuming each int requires 4 bytes. Let me use a different color. 100 pointers. Par, there are no 100 pointers. There is only one pointer. Hotel. And if it is a short int, then perhaps 100 into 32 into 2 bytes. If short int is allocated 2 bytes. And if it is char, then it is 100 into 32 into 1 byte. Are you all with me here? and 0 or 1. Okay, 0, you use 0 for presence of something and 1 for 0 means male, 1 means female, or the other way around. Great. But then what is the challenge problem? No, we said it's a 100 floors and 32 rooms. We can just get away. So one of you already mentioned this. We can just do, I will write here, we can just get away with the int hotel 100. You know, each element is a, if it's an integer, there are 32 bits in it. B0 to B31. Okay, B0, B1. So if for room 0 has a male, you put 1, and room 1 has a female, you put 0 here, so on and so forth. Does this make sense? The encoding of information, does this make sense? But you need to know how can you make this bit equal to 1, or you can make this bit equal to 0. You know, or so this information you need to know bitwise operators. Okay, if you need to study bitwise operators. Yes. How do we set a bit? How do we unset a bit? Okay, so you need to learn about bitwise operators. So there are the bitwise operators. There are operators and, or, exclusive, or negation. There are few bitwise operators that are there. You need to learn these operators to be able to manipulate these bits. The purpose of this challenge problem is twofold. First is that given a problem, the representation of the problem, the representation of the information, it can be done in many ways. If you see, when you compare this, this base representation, if you don't pay any attention, this is representation R0, and this is whatever this is representation R1, this is representation R2, this is representation R3. What is the savings that you get from R0 to R3? How many times savings you will get? You get 32x savings. 32x or even more, 32, yeah. Okay, 32 times savings. So what happens is, if you have memory, let's say 8 GB RAM, if you have memory 8 GB RAM, and how many floors in representation 0, how many floors you can handle? How many floors? Here we took 100, right? So largest, okay, how many floors you will be able to handle using representation 0? So in representation 0, if there are k floors, k into 32 into 4, it should be less than or equal to 8 GB. 8 GB is 2 power 30. So no, this k is should be less than this. But whereas in representation 1, so what happens is this will be like k into 4 is less than 8 into 2 power 30. So what happens is you will be able to handle 32 times larger information. So what seems to be so many times down the lane, when you solve this problem doesn't make sense. I mean, who will have that many number of floors? But down the lane, like for example, yeah, so down the lane when you are working on some problems, you see that the size of the data is so large that it wouldn't fit into the main memory. And so you have to resort to alternate mechanisms to store data on the files, move data from the file to memory, and work like that. And then but then if you just change the representation strategy, then what happens is you might be able to get away with just storing all the data in the memory. It will have huge advantage because it reduces the complexity of your program, number one, and you will be able to handle, if all the data is in the memory, the performance is really good. You don't need to go and access the disk. Like that, there's a whole lot of advantages that you can get by using a alternative representation strategy. And this is a kind of in so couple of 2 years later, 3 years later, when you go for interviews to companies, they'll ask questions such as this. Then you need to ask questions such as, what is available RAM to me? What is the data size to me? Without asking questions such as, what is the data size? What is the available RAM? And based on that, know whether you have to, what is the kind of representation that you have to go for? Is performance important? So what are, these are the questions that you need to ask. They will not give you all these things for you. You have to ask these questions. When you ask these questions, they know that, hey, this guy knows stuff. Okay, he's asking all the right questions. Not only in interview, when you're solving a real problem, these are the questions that you need to ask. Okay, what is the size of the data? What is the right representation? Are you all with me so far in the discussion? Doing all right? Great. Now I have a so I have one more problem for you. That is, instead of the room containing either a male or a female, instead of the room containing either a male or a female, if it could be empty also, a room could contain male, female, or it could be empty, then how will this problem change for you? Well, whether the representation strategy, whether representation R0 still works, R0, R1, R2, do they work? If you use, if a room can contain male, female, or empty. R0, will we be able to handle empty rooms using representation R0? R0, R1, R2, R3 will work because 0 male, 1 female, 2 empty. Okay, we just have to use a code for empty. But for R3, what do we do? How many bits are, if there are 3 states are there, when there are only 2 possibilities, we use 0 and 1 to encode 2 possibilities. But when there are 3 possibilities, how many bits are required? So the strategy that we use is 0, 0, 0, 1, 1, 0, 1, 1. So this is male, this is female, this is empty, and this representation goes waste. 1, 1 does not correspond to anything. We require 2 bits to encode 3 possibilities. Are you all with me on this discussion so far? The last one. Great. No, if you use char, no, why use 8 bits when you can get away with 2 bits, Santrupta? Santrupta. Sorry, Santrupta Singh. Sorry. Okay. And this is where the precise thing about 100 bytes is coming. 100 into 4 bytes, 400 bytes. This is where that the origin of that. So what is this? There is this question. I think I discussed it in one of the, mean minus standard deviation. Yeah, we discussed it. So mean. So if you take a distribution like Gaussian distribution, so if you have something like this, so this is, let's say this is the mean. And when we compute standard deviation, so the range mean minus the one standard deviation, mean plus one standard deviation. So all the area that falls under this, this is, so this is one standard deviation. Two standard deviations is, this is one standard deviation. So you go ahead and, did you study Gaussian distribution somewhere in your high school? +1, +2, yes or no? Statistics, you didn't study? Yes, no, okay. Anyway, then normal distribution is same as Gaussian distribution. Or it's the same for anything, okay? But if you are not sure about it, you just think of this. What you know how to compute mean, you know the formula for variance, standard deviation. You know, for formula for variance and standard deviation, you know. Okay, and then this is very simple. You don't need to understand all the theory. One standard deviation is this interval. And two standard deviations is this interval. Okay, because so. No, just look at what I have written, Arya. So the one standard deviation defines an interval and two standard deviation also defines an interval. We want to see the students how to store data in bits and extract. Thank you, David. Yeah, second standard deviation includes first standard deviation also. Yeah, because that's the inclusive interval. No? Yeah. See, I request you to put messages on the general window. Unnecessarily don't put it on the direct message thing, because I have to repeat the question and it's out of context for others. So there is this question. So do we need to miss out marks from create a histogram which ranges from 0 to 9, 10 to 19? I think I made a mistake there. Maybe it should have given 0 to 10 open interval. Yeah, so so here I think perhaps clear. So maybe perhaps a better thing is 0 to 10. Does this solve the problem? 0 to, there is one question, and 20 to 30. Okay, please use this. Okay, change the problem to this. Now, there's a good question being asked, but question is asked privately. So, okay, so nice. And about bit manipulation, there are two options for for about bit manipulation. There is one video lecture from last year. I can just point you to that. You can watch it. I will decide what to do. Okay. And otherwise, I can talk about it in the next class also. A question on how do we manipulate bits. Marks are in float, not integers. Don't you fight for fractional marks or give me half mark here? Okay, so marks are in fractional. Yeah. And if you get 100 marks, then he's an outlier. We will. Okay, so 100 we can perhaps, I don't know what to do. 100. 100 is a special category. Yeah, we'll have 100 in the last interval. Yeah, let's have 100 in the last. Yes, yes. How to proceed with histogram? So what do we do for histogram? You just maintain how many bins are there? There are 10 bins, right? Yes or no? You just have a data structure int and initialize all of it to 0. And when you see some marks, no, you kind of divide the marks with, I don't know what. The dumbest strategy is you check if marks lie in between 0 to 10, add it to increment hist of 0. Okay. But there are better ways of doing it. Okay, if this lies between this plus is to 0, like that. This is one way of doing it, but there are Hardik Sharma has a better way of doing it. Yeah, that's true. You just need to work out and see if it's looking all right. Hey, don't use binary search, Mayank. Why do you want to use binary search? You don't need binary search, na? What are you searching for? Yeah, what Hardik suggested, Tejas suggested, so some of these things, they should work. Okay, shall we conclude today's lecture? They're all right? Good, nice. I'll see you. Is Saturday a holiday for us? Okay, great. No. Don't worry. No, nothing like submitting assignment by 5 tomorrow. You'll get time. You are more anxious to submit the homework than me. I am not at all anxious. Take your time and do it. Okay. Okay, then. So we will catch up. Happy Christmas. Merry Christmas. No, don't worry. Tomorrow you will. We will open up the OJ for assignment 1 and assignment 2. You will get time to solve. Don't worry. Problem assignment 3 will be out today, tomorrow, max. And I will see you next week. Okay, last week of 2021. Yeah, so okay then, guys. Thank you. Merry Christmas.